So I'm Eyal Trabelsi, and let's face it, we got a lot of options when we're gonna pick a technology or a vendor. And my reason here is to help you pick the right solution for you, although it's like finding a needle in an haystack. So a bit about myself. I am an architect at Bigabid. Bigabid is an edtech company, which automatically means a lot of predictions, tons of data in real time. And in the past, I worked with medium-sized companies like Yotpo and huge companies like Salesforce. So I would like to share with you my past experience. And to be frank, I don't expect this lecture to present any groundbreaking ideas, but I'm convinced that I will provide significant amount of clarity. So in my opinion, machine learning goal is to bring value to a business. And in order to bring value to the business, your predictions or insight must see production light. No matter how sophisticated your model is, it's worth nothing if it's not in production. And there are several steps that one should go in order to get there, from collecting the data to the building the model, deployment, evaluation, serving, and so on. And because there are so many steps to get there, there was a gap in technology that boomed many options. Some of the options focus on one specific criteria. We call those best of breed, and others focus on more than one or even the entire flow, and we call them all-in-one solution. And since we have so many options out there, it's tough to pick the right technology for you. One will say that he used GPU a lot. Other will be glad that he was ex-Googler. Another open source used Kubernetes. One even invented a new buzzword. And someone will say that MLops is dead and they are ML platform, which is obviously the same. And the thing is that if you choose poorly, it will affect pretty important things. It will affect the delivery times, the satisfactions of your business owner and your developer, hiring, and capabilities. And in terms of capability is not only the performance of the model, but the fact that you can create even new models on things that you don't have currently. So I want to give you a simple recipe for picking a vendor or a technology. And to be honest, this specific recipe is very generic, but in each of the steps, I will give you the MLops perspective, and we will go over it right now. So first, you need to define the functional requirements, the resources that you got, and the constraint that you live in. After you have those written down, you can search for several potential solutions, like don't spend a lot of time on it. Then you should only evaluate few promising solutions. Even one is okay. And then you should decide whether you pick one vendor, one technology, or another, or even not pick any of them. And remember, it's okay to not pick any of them because you don't start with clean sheet most of the time. Most of the time you have like model monitoring done very basically, and you want to go to the next step, and you want to make sure that the value that you're gonna get is more than what you're gonna give the vendor in terms of resources or cost. So the first step is to define the requirements, resources, and constraints. And although this sounds extremely boring, do not skip this step. Even if you take a short talk over coffee, it will take you very far. So the functional requirements depend on the ML platform component. So you probably know about experiment tracking, feature store, model registry, model serving, and so on. Since this is quite short talk or medium talk, I will focus only on two. For example, if I'm gonna try to do model monitoring, I will try to understand basically the model performance. If I have drift, local drift, global drift, bias, anomaly detection, and so on. Specifically in EdTech industry, you care about drifts because you use third-party data. In Salesforce, for example, we cared mostly about model performance. In terms of model serving, which is a bit different, you care about whether you can serve the data offline or online. Even doing some federated learning can be cool. If you can do some sophisticated deployments. And in this example, as an EdTech company, we care about more sophisticated deployments like A/B testing, multi-round bandwidths, and so on. And in terms of Salesforce, we cared more about offline and online serving. In terms of resources, this is pretty generic. It's not MLops specific. You care about the time to value, the time to maintain it, how much does it cost you to own this component, and the cost of mistake. And obviously you care about what team you got in terms of size and expertise. How many data scientists, how many MLEs, and how many DevOps. Obviously, in my opinion, if you're gonna build your own solution and you go to Kubernetes, I would expect you to have a DevOps at end or a very strong MLE. In terms of constraint, you got both general constraint and ML component specific. You got existing integration if you want to integrate with a data warehouse. If it's gonna change ownership between MLE and a data scientist or the other way around, you should know about it. Most of the vendors don't support all the clouds, so this is a good constraint as well. On-premise multi-tenancy, if you are in a highly regulated vertical, then HIPAA compliance and stuff like that is critical. And obviously, if the component is not available when you need it, it's useless. And you should use these constraints to filter out the options in the next step. But we will see now the more specific constraints for the ML components. And I will take here, for example, the feature store. In terms of feature store, you care about latency, throughput, scale, stuff like that. The latency in the inference, in training, you care more about throughput. I will be more accurate here. And in Bigabid, since we are an EdTech company, we serve prediction in real time. So latency is the most important thing there are. And if I use this constraint, it's gonna filter out most of the options I got. In terms of model serving, it can be the hardware, if they support GPU, CPU, and so on. The types of and models and versions that is supported is a huge topic. Most of the time, vendors take a bit of time to support a newer version. Yeah. So after we gather the requirements, the constraints, and so on, we need to search for potential solution. First, you need to understand the buzzwords and the technical terms. Then you should search in Google or speak with the community, and we got awesome community. Obviously, we got MDLI, we got MLops community, and we have MLops TLV, and people love to share what they do. Then you should curate a table of technologies and vendor, and only keep the most promising ones. And in order to keep only the promising one, you need to filter by the most restrictive constraint. If you are in a multi-tenant environment, probably you can filter out 90% of the vendors. And the same goes for any other of the constraints I showed before. We got here a list of buzzwords for each of the component. You just need to know what is bullshit and what is not. Focus on what you need. It doesn't matter if a feature store is in Kubernetes or on Amazon, if it gives you the latency, the throughputs, and the functionality that you need. It just sounds better, maybe for marketing, but I'm not in the marketing vertical yet. In terms of your options, so you can look for buying a solution or building a solution. And this is a very generic table that shows that if you want to get value fast, you need to probably buy a solution. Otherwise, you should building is a bit slower. But if you build it and you have the right expertise in terms of resources, your flexibility is endless. But this is very generic. So I want to give you my opinionated take on that. If it's extremely easy to build and maintain and don't take a lot of time, just build it yourself. It might be enough for you. Otherwise, if it's ROI positive, you should probably buy it, but you need to make sure that the shelf is not empty. There is a reason why Google and Uber and all of these just building their stuff, because nothing, no vendor have their requirements and constraint. And if otherwise, you should either build or skip this component, depending if it's our ROI positive. And the same goes for all-in-one vs best of breed. So you cover more in all-in-one. In best of breed, you cover smaller components. But in all-in-one solution, some of the functionality may be basic, but you have one interface. And in best of breed, you have the best available capabilities, but you need to do a lot of integration and make sure everything is connected. So in terms of all-in-one vs best of breed, in a more MLops perspective, I think that all-in-one solution is awesome only if most of your use case is easy. And remember, it's okay. Most of us are not Google, even us. And if you are in a more constrained environment, then you should probably go to best of breed, and you can combine both. But if you combine both, you need to make sure the integration is as slick as possible. The next step is to evaluate the promising solutions. So try to engage with users from the community, with the vendor, and understand the viability, the feasibility, and the usability of the solution. And have some Israeli chutzpah. Ask the vendor or the person if they know about big companies that use it, what differentiate one solution from another, can they link you to another customer? It works. In terms of MLops, again, the industry is not mature. We must face it. So it's critical to understand the touch point that you're gonna have with a technology or a vendor. What is the support? How many releases occur? When a release occurs? If it's your decision or going behind the scenes and you are not aware of it, and know about the roadmap. And even if you talked with me or some other person about a specific scenario, do a minimal POC, because it's worth the effort. My experience may be different than yours, and you might not articulate good enough your use case, and I may give you not optimal solution. So obviously the amount of effort of the POC depends on how much value it gives you, and it depends on the size of the company. And don't be swayed by buzzword. Shiny is not always better. And to be honest, in 10 years from now, someone, probably junior person, will look at the technology that you chose and he will say it's not advanced enough, it's not nice, it has a lot of problems. But if it do the work good enough, it's good enough. The last step is to decide, basically. And in order to decide, I think you should create a table that is similar to the table you created on the second step, but with only the options that you evaluate. It should be a few, depending on the size of the company, obviously, and describe the functionality and the constraint that you meet. And it's always a trade-off. I don't think that unless you have a very common use case, I don't think that all the constraints and features will be ticked. So you need to consider the trade-off, and please avoid politics. It's not fun. And when you decide, think about the cost of mistakes and when you should stop, when you should do the reverse. Be wary of human biases. Complexity is not always means smart. New stuff doesn't mean it's better. Things that are not invented in your company can be good enough. And remember, there is no perfect solution. So this is, again, the recipe. I want to go over very quickly on something that we did. We had some basic monitoring capabilities that only measure model performance, and we wanted to do some RCA, local and global drift, and we are working on a very imbalanced data sets, and we have huge scale. So in terms of functional requirements, we want local, global drift, and RCA. And in terms of constraint, the most constraint thing there is here is imbalanced data set and the scale. And that alone filter us in the second step, like most of the vendors at that time. We were left with only two. And then we evaluated both, and we decided to go with Fiddler, although we knew it will take us some time and that the solution is not perfect. But this goes to tell you that if you pick the most aggressive constraint, you don't need to spend a lot of time on it. And obviously, this recipe depends on the context and on the time you are running. Maybe in 2 years, the industry will be much more mature. So few tweaks that I can think of in terms of the size of the company. In terms of requirements and constraint, if you are in a small company, look at the present. As a medium company, you can look at the near future. And as a bigger company, look on the long term, but not on fictional stuff. You will probably not reach Google scale. And if you do, you probably don't need this slide. In terms of process, you can be more lightweight as a smaller company. It can be semi-structured, or in Israeli, shchuna. In terms of medium company, you need to be structured, and as a bigger company, it must be extremely structured with design doc and stuff like that. And lastly, in terms of the decision, as a smaller company, you should focus only on the value. And as you grow bigger, you should also consider the cost of mistakes. If you got any questions and opinion, feel free to reach me out on LinkedIn or whatever. And I want to thank Ori and Adi for organizing this amazing conference. I enjoyed the content, and that's it.